routing and remote access services from Windows 2008. Here's our topics. We'll differentiate between static and dynamic routing. We'll look at the role of RRAS in modern routed networks. Then we'll look at the steps to install RRAS and the steps to enable RRAS. Well, as you're probably well aware, routing is the process of forwarding data packets between networks or subnetworks. And as we know, these networks or subnetworks are broadcast domains. Therefore, routers create broadcast domains. And the devices that we use to route these or forward these packets from one network to another is what we call the router or the gateway. Now, the routing process is going to use a set of routing tables, various protocols and algorithms to figure out the most efficient path for forwarding the IP packet across typically multiple routers, often hundreds or thousands of routers, especially on the internet. Routers greatly enhance our scalability of our networks by terminating layer 2 collisions and broadcast domains. So before we even get into the Windows 2008 service of routing and remote access, we want to understand one of the main differentiations of routes and the difference between static and dynamic routing. Now let me just say this. I'm using a symbol here for what we call a multi-layer switch. And so when we say router or gateway, it could be a wide variety of devices. It could be, in our sense, a Windows 2008 server that's running routing and remote access services. Typically, if we have it on a server, this server will have at least 2 network interface cards. In other words, it's multi-homed, so that we have one network interface card on one subnet or subnetwork and the other NIC on another subnet or subnetwork. But it could also be a dedicated router device like Juniper or Cisco. It could be a layer 3 switch or a multi-layer switch. In other words, a layer 2 switch that also has a route processor or a modular router built into it. So it operates at data link layer 2 and network layer 3 of the OSI model. And if it's a multi-layer switch, it can also function at layer 4 as well. As a matter of fact, you could have a firewall device or a firewall appliance like a Cisco Adaptive Security appliance. Well, these could be routers too. Anything that connects between more than one subnet or subnetwork and can route packets between those networks using routing tables and either static or dynamic routing. Well, regardless of whether your router is software-based, which is a service running on Windows Server 2008, or hardware-based, which is a dedicated routing device like Juniper using its JUNOS, or Cisco using its Cisco IOS, you still got the choice of static and or dynamic routing. Now in static routing, and remember we're dealing here with these routing tables, and we'll look at the construct of the routing table coming up in the next lesson. But the bottom line is this: in static routing, as an administrator, we have to manually enter and update the routing information on this router and if it's Windows 2008, we're using the route command. So we have to populate and tell our router, say our router or multi-layer switch here, we have to basically tell it about all of the remote networks that we have to connect to. Now this is fine in a small network where you've got maybe 1 or 2 other networks or subnetworks, but as the number of networks increases, it also increases the time and the effort that it takes for administrators to maintain these routing tables. And also, whenever a user is involved typing in commands at the command prompt, there's always more chance of having user error. And misconfiguration in static routing is a key aspect of troubleshooting in small to medium-sized networks. As your network grows and moves from the medium-sized to the enterprise network, static routes are going to be administratively impractical or overwhelming. Now, one good thing about static routing beyond that is you have lots of control with static routing, but we also have more security, because when you are using static routing, you are not broadcasting or multicasting routing table information across your network, which is vulnerable to all different types of network attacks. So you get higher control and more security with static routing, but again, more overhead. Dynamic routing allows you to use a dynamic routing protocol, and for the purposes of Windows Server 2008, we're looking at RIP, Routing Information Protocol, and OSPF, Open Shortest Path First. And also, we're looking at RIP version 2 for IP version 4, and also OSPF version 2 for IP version 4. By using dynamic routing protocols, you can reduce the overhead involved in making manual changes to the routers in medium-sized to enterprise networks. Now, when should you use static routing and when should you use dynamic routing from a Microsoft standpoint? Well, let me give you some bullet points here to kind of give you some guidelines for a real world and for your exam. The best situations to use static routing is when there's little change to your routing table, or in other words, the routing table information is more static. Also, if based on the size of your organization, having the extra overhead and the extra configuration, if that's acceptable to you, then static routing may be a good solution for you. If you want to add a fixed default route to a demand dial interface, and that'll make more sense a little bit later on, then static route might be a good solution. Maybe you want to improve network security by not having routing table information and advertisements and updates automatically sent over your network. And also, by doing static routing, you don't have the extra network traffic that's generated by dynamic routing protocols like RIP and OSPF. Dynamic routing, however, is a better solution when you need to automatically update your routing tables because you have a lot of routing devices, or if it's a dynamic organization or a growing organization where you plan to have lots of changes to the routing table information. Or if you come into a situation where the existing routers are using the same dynamic routing protocol, you probably want to stick with that solution and not go to an overall static routing solution. If you have a demand dial interface that supports auto-static route entries, you might want to go with dynamic routing. And this last bullet point, well, it shouldn't be here, so let me go ahead and erase it. So there you go, static routing versus dynamic routing. Now, even though there's an explosion in using things like DSL and cable and satellite for network connectivity, Windows Server 2008 still supports the routing of packets over ISDN lines and analog phone lines using the point-to-point protocol, which is still very common in rural areas and in small to medium-sized businesses. Now, this routing is referred to as demand dial routing. Let me jot that down here for you real quick. Demand dial. In other words, whenever you need the circuit, you're just going to dial it up on demand or on an ad hoc basis as needed. So the router has a demand dial interface that is used to represent that particular point-to-point protocol link. Demand dial interfaces can be used to create two different types of connections. On-demand connections, which are excellent if the cost of using the link is time-based. For example, you're making a long-distance analog phone calls and you're charged on a per-minute basis. When using on-demand connections, the link used to forward data will terminate as soon as the configured amount of idle time is reached, and you configure the amount of idle time on the calling router. Then you have persistent connections. Persistent demand dial connections have a fixed cost, and they use dial-up WAN technology that's connected 24 hours a day. This could be local calls using analog phone lines, it could be leased analog lines, or it could be flat rate ISDN that has a fixed cost. The connection is always active, and a calling router will immediately try to establish a connection if the persistent connection is lost. Persistent connection behavior is configured on the calling router itself. Now, the type of demand dial connection is going to determine which method the demand dial router uses when it's updating the routing table information. So, for example, on-demand connections will use static routing. Persistent connections will use dynamic routing with routing protocols like RIP and OSPF.